Okay, so hello everybody. Thank you, Marco, for inviting me. This is my first time participating in such an event. I had the opportunity to be part of the two sessions today and one question and answers session. So I really like how you organized the event, and I'm really happy to be part of the Microsoft Learn Student Ambassador yearly Edu Summit. So today, as you all know, we are going to talk about the machine learning, especially the Microsoft part of the machine learning, which is called ML.NET. And I really encourage all of you to ask questions, to initiate a discussion, let's connect people and let's discuss the ML, because as you had opportunity to see in the session for the artificial intelligence, I will just confirm what was said there, that machine learning and artificial intelligence are fields that are everywhere and that are part actually of our daily life. So I'm pleased to talk about the machine learning and to talk about my experience with ML.NET. So let's start. First of all, who am I? I'm a senior .NET software developer working primary and developing my expertise in the web development, but I have experience with working with mobile applications, closed-platform solutions, as well as desktop applications. And currently I'm a PhD candidate and machine learning researcher here in Skopje, but we are working on different international projects. And I'm working the machine learning part. I'm researching the machine learning and utilizing the machine learning techniques in the field of bioinformatics, more precise in the bioengineering part. So we can of course discuss and connect if you find interest in this area as well. In the meantime, I'm also a technical trainer for the web development, for C#, for programming, for object-oriented paradigm. And in the meantime, also, I'm part of the Macedonian .NET community and everything that is related with the data science and especially programming. I would wrap everything of this as tech enthusiastic. At the end of the day. So here you can find my LinkedIn profile, you can find my Medium account, ResearchGate, where I'm posting my articles, speaker deck, where you actually can find this presentation that I'm sharing right now. And of course, the GitHub account where the code of this session will be shared actually is there already. So feel free to explore it or wait while we go through it together. So I would like to dedicate this presentation to one very special man named Hayan Salmani. He was one of my best and most influential people in my career. So in honor of him, I would like to dedicate this presentation to him and to all of you, and to actually start spreading the enthusiasm that I have in the field of engineering, but more precisely in this situation in the machine learning. So how we are going to organize the session map, the session roadmap actually. I will start with talking about the machine learning. What is it, the definition of machine learning? And I think this will come very naturally and complementary with the session that we already had about artificial intelligence. After that, we are going to talk about the ML.NET. That is the main topic today. When, where, why, and what is it at the end of the day. So continuing to the model builder and the AutoML, which are the fundamental concepts of the machine learning .NET framework. And I will also mention and address some casual or usual key feats that you should take in consideration when you're thinking about the machine learning. And of course, the most important part, according to me, and I believe that you'll feel like that as well, will be the demo time or the ML.NET in action. And we are going to conclude the session, of course, with taking the key aspects, the key action points from this session, and hopefully you will be encouraged enough to start using the ML.NET since now. immediately. So let's get rolling, folks. What is machine learning? Machine learning is a branch of the artificial intelligence. So the artificial intelligence, like a field, is more broader than the machine learning. So machine learning is one specific application of the artificial intelligence, which is mainly focused on actually making the machine smarter. So, but how? Without being explicitly programmed. So this means that with the machine learning, we are using some kind of algorithms, of course, data, and we are trying to make the machine smarter, machine to think about the data and to develop some rules. I would like to talk a little bit in details about this concept. So I strongly believe that most of you, if not all of you, are coming from programming background. So you're very familiar with this part of the image, that the classical programming is actually a set of rules and data that are producing some kind of answers. So we have standard applications. I mean the applications, for example, a web application, and we need to build up some logic that will produce some output. So we have a data, of course, we are using databases and so on, and we need a set of rules combined with the data to produce answers, to produce the output. That's the story, and that's the fundamental part of the classical programming approach. In the machine learning field, especially in the supervised machine learning, we have the data again, but now we are trying to derive the rules or the actual logic by inputting the answers. So we have the data, we have the answers, now we need the rules. So the machine can explore the data patterns, can explore the correlation between the data, can maybe produce a data matrix, and after that produce rules that will be around our concept of interest or around our challenge. So
yes? One question.
Yes, of course.
There is knowledge base versus artificial intelligence. What's the difference?
Knowledge based versus artificial intelligence. I would say
Yes.
that machine learning is actually dividing in multiple fields. So we have like supervised machine learning, unsupervised machine learning, reinforcement machine learning. So I believe that the question is regarding this topic. So in the supervised machine learning, we have the data, but we have a historical data with answers. So we can like teach, we can train the machine learning algorithms, the machine learning logic, to actually learn what's specific for our data, to learn about the historical data and learn about the outputs that we already had, the answers, and after that try to predict or to find a correlation in the data that is new to the machine learning concept or machine. We have unsupervised learning, which means that we have the data, but we don't have a clue about the answers. So here we have the recommendation system. We have actually here the clustering algorithms that can provide grouping of the data. And of course, we have the reinforcement machine learning, which means that the machine can, the algorithm can learn after making the first predictions and after making some errors. So I believe I addressed the question, or?
If it's not still clear, please write again or maybe describe a little bit more. And yes. There is another one, which is does machine learning requires an advanced level of programming?
Yes, I will go through that.
Perfect.
So please be patient. You will see and you will decide by yourself. But great question. Thank you for this. Okay, so some learning trends, artificial and machine learning trends. I know that there are a lot of sources that are making research under these areas, but I would briefly just show one of them. This is the Algorithmia report that was made in January 2021, which means the beginning of this year. And why this is very interesting, because it is presenting the customer experience and process automation for the AI and ML use cases. And according to the case that we are going to talk about today, you can see here that 34% is dedicated to the acquiring new customers in the customer acquisition field. Despite that, we have 83% of organizations that are increasing the budgets per year. So as you can see here, we have the budgets for 2018 to 2019, and here we have the budgets from 2019 to 2020. So you can see here that we have like increasing the budget. So we have a growing trend of increasing the budget for the artificial intelligence and machine learning fields. This data is actually from, if I'm not wrong, from over 400 leaders that are part of companies with more than $100 million income per year. So, I mean, these are relevant, but you can find, of course, a lot of resources that are very similar or maybe even better granulated in the field of the budgeting of the companies. So what, where, when, and why machine learning? I mean, machinelearning.net, ML.net. So ML.net is open source, cross-platform machine learning framework, which is made and focused for the .NET developers. But actually, I will show you that anyone can use the ML.NET, especially for the part of prototyping and building models in very short amount of time. That's why it is very popular, and that's why I really like it. So ML.NET, you should think about using it immediately, and also think about entering in the field of machine learning through the ML.NET, and you will see why. So from zero to hero, how ML.NET was born. It was started as a very initial research project in Microsoft that was related to the text mining and search activities. That was the main domain, that was the main field of interest. And after that, it was established as a learning code. Learning code was the name of the project, or the Microsoft internal framework, which on 7th of May 2018 was released for external use and was called machinelearning.net. So ML.NET was born in 2018, and now I believe that some of you were actually part of the .NET conference, which was organized this last November actually. Now ML.NET is part of the .NET release schedule and currently in 1.7 version. So here you have, through the presentation you will find links which I found that are going to be very useful for you. So this is the GitHub repo, which means that, and which actually proves that machine learning and ML.NET is actually open source. And here we have the roadmap of the ML.NET and how they are planning to release another additional features and to support another scenarios that are not part of the current version. So ML.NET, after all, and in general, is actually .NET. So it empowers people to stay in the .NET ecosystem, and everything you need to know is to have like C# or F# coding skills. So talking about the environments, the integrated development environments, you can use the Visual Studio, or you can use the Visual Studio Code as you prefer, and what you find that is more useful or more appropriate for you. And the most important, I will address the question that we have before 2 slides, that no deep data science or machine learning related experience is needed. Besides this, it does not hurt if you have a machine learning or data science background as well. But we are going to talk about this concept. The main point here is that with ML.NET, we can very fast, very simple, go from experiment to production concept. And what is very interesting for ML.NET is that you can utilize, you can apply the ML.NET in your already existing applications. Doesn't matter if it is MVC web application or desktop application or mobile application. You will see very soon that it's very, very easy to integrate, consume, and deploy the ML.NET within your existing, or maybe within as part of your applications that you are going to start soon. And here we come to the industry challenge. This is very hot topic because we have data science field, we have data scientists, and we have software engineers. I'm a software engineer. I'm working as a machine learning researcher for my academic purposes. But for example, I will take one simple example. We have data scientists that they are starting their job and working in one framework which is called, one platform which is called, which can be, of course, Jupyter Notebook. So it's a workbook where they utilize the Python and, of course, the scikit-learn as #1 library in the Python, based on Python in Jupyter Notebook. So the data scientists actually are developing the models, are creating, building, optimizing, evaluating the models, and generating the models. But what when the models should be actually put in production? So that's the one part of the story. The other part of the story are the software engineers. For example, I'm coming from the Microsoft, my background is Microsoft related. I mean, I work in Microsoft technologies, so I'm utilizing the .NET framework, the .NET Core framework. And the point here is that how we are going to incorporate a model that is built in another platform in current existing .NET related applications. So that's the industry challenge. And that's the technological gap that we are facing now. There are, of course, solutions, and there are ideas how we are going to address this. But the point here and the industry challenge now, the hot topic for discussion, of course, is how we are going to put our model in production. Because that's the main point. We can experiment, we can prototype, we can automate something, but we will get the real value as soon as we put that model and that algorithm as part of our applications and productions. So
two questions. Yes? Sorry again. Yes, so the first one is, so the features are more or less same like in .NET?
Yes, it's actually a .NET. ML.NET is .NET.
Okay, and the second one question is the last one. Are you able to use Python on the ML.NET framework?
I will talk about that. You can integrate Python models. I will show you how you can do that, and I will show you one direction because that was the most interesting topic for me. Recently, I was really exploring this topic, and I also blogged one article, one guide on Medium, which is now actually published on Towards Data Science. So I will show you that directly, how you can do it. And
one more just pop up, okay. We are basically fighting the industry.
How do you mean fighting the industry? We are not fighting the industry. We are trying to actually use and utilize the concept of machine learning as simple as possible. So using the ML.NET, we are trying to actually create, train, and consume and deploy models within our application. So we will be able to actually automate part of our business domain or business logic. That's the main idea.
And which programming language would you say is best for machine learning?
Very interesting question. There is not actually the best programming language, not just for machine learning, but I mean that for everything. There are a lot of tools, a lot of programming languages that are solving similar, identical, or different, that are addressing different use cases. So I will say that the best programming language is the programming language that you can learn and you can utilize in order to solve a challenge. Not a problem, but a challenge. So, okay, so I will continue and say that our deployment horizon now is that we would like to actually utilize the ML.NET and the machine learning in general in the console application, mobile applications, web applications, as well as the desktop applications. So we can use with the MVC. In desktop, we can use with Windows Foundation or maybe with WinForms. In mobile, we can use Xamarin or multiple platform MAUI on Microsoft, and so on and so on. The main point here is that we can use and we can utilize the machine learning.NET using the .NET Framework version 4.6 or above, or .NET Core with version 2.0 and above. So now let's talk about the model builder and the AutoML as a fundamental concepts of the ML.NET, mainly for prototyping and automating the solution. So now we are starting to talk about we are going to drill down the main concept. So be careful, guys, and this is the actual power of the machine learning.NET or the ML.NET. So the model builder is a wizard that is built on the top of the ML.NET software developer kit. So I'm going to present that in Visual Studio as well, but this is something that is trying to find the best algorithm that is suitable for your use case and data. And you will see how easy it is to do in Visual Studio. Also, this model builder is actually taking care if the data is changed over time to actually try additional algorithms and to try to adapt to the changes that are made. And of course, with all of this, it allows quick prototyping, which is very, very crucial topic in the machine learning field. I'm also working with Python. I'm working with R programming. I'm working with ML.NET. That's why I'm saying that there is no best programming language. All of them can be utilized in order to solve a problem more appropriately and more efficient. So the quick prototyping, according to me, is one very, very crucial and important and significant process that enables us as engineers to find the best solution and the best algorithm that will fit for the use case. So of course, the model builder is supported by Visual Studio Code, and CLI. So in Visual Studio Code, we have the UI for the model builder. Of course, you can use in Visual Studio Code. There is a community extension there. And with the CLI, command line interpreter, you can use it on all platforms, meaning Windows, Linux, and of course, Mac. So the point here is that we have a data and we need to generate a code. What code? In terms of this presentation, I will generate a C# code. So we have the model builder to go through importing data, training models, evaluating models, and generating the final code where we can actually reference and consume the algorithm.
Another question.
Yes, of course. Sure.
RStudio integration.
RStudio, no, yeah. Yes, RStudio is currently we cannot integrate the RStudio because that's a different world. Okay, so we can integrate if you are familiar with TensorFlow or PyTorch or ONNX. I will talk about this. We can integrate the models into the ML.NET using these concepts. There are also packages for this, but R for now is not supported. According to my understanding. So I will give you directions how you can utilize, for example, and integrate Python related models using scikit-learn into the ML.NET, so you can investigate and explore a little bit about this topic. So besides the model builder, we have the AutoML, which means automated machine learning. And as you can see, the model builder is using it behind the scenes. So via the UI or the CLI that we already mentioned. So the AutoML is actually the experimentation process. So we have fast prototyping and we have fast experimentation process. At the end of the day, we would like to have like a process where we will have raw data set to put it in deployable ML model pipeline. And with automated machine learning, this is crucial, and this is, of course, doable within the ML.NET framework. So you will see at the end of the presentation that I'm going to generate all of these files, and you will see that how actually this flow works. You will see the complete process, and I will explain the generated files, and I will of course consume them within different types of applications. So besides everything that I've already mentioned, there are, of course, some cases which we should really take in consideration when we are thinking about the machine learning, the artificial intelligence, because today, you know, a lot of people are taking in consideration using the machine learning and the artificial intelligence. I would like to mention here that the machine learning as a field, as an application of the artificial intelligence and the artificial intelligence in general are very comprehensive fields and topics to learn. So we need mathematics, we need statistics, we need a lot of knowledge that is related to data analysis, data science, big data concepts maybe, and so on. But the main point is when you're going to deep dive into the machine learning field, you should take in consideration some key feats that should be part of your journey. So I would like to...
Before we go
yes?
to questions.
Okay.
Is there an option for version control for machine learning models on this platform?
Yes, of course, there is. It's simple as we are versioning our code. So yes, of course.
Okay, and the next one is, so it doesn't matter which language you choose to do prototyping.
It means because you can use C# or F# for prototyping, but be careful and be patient because I will show you how you can actually use the prototyping feature without using any language. Okay, so you will see that even proficient skills of C# are not needed for the prototyping part. That's the most interesting part after all. So the first thing first about the k-feats that machine learning is not magically solving our problems. That's the utopia scenario, but it's not the case. So first of all, we need to take care and to understand, deeply understand the business logic, the business domain, the expertise, the point of interest in our scenario. And as soon as we do that, we should actually take care of the data analysis. That's the most important part because the data is everything in these concepts. And taking in consideration these two aspects, we should guide the machine learning, or we should apply the machine learning field in order to automate some process, as well as to make that process more efficient using the machine computational power and potential. So I would recommend to all of you to begin with KISS principle. Keep it simple and stupid and start with the most basic scenarios. For example, in my case, that was the scenario that I'm going to present you today, the classification algorithm and the classification and regression approach in the supervised machine learning. Why I'm mentioning all of this? Because it is very important at the beginning to not like, because I would say like that. Machine learning and artificial intelligence are two broad and comprehensive fields. So it is very easily for you to be trapped in a rabbit hole. You're going to take one aspect, one topic, and you will say, oh, okay, I know this. But you will see that as you're reading more about that topic, there are a lot of links and resources that you should take care of. So as soon as you dig down and drill down on other resources, you will find yourself, oh man, these are a lot of resources. This is too heavy, too comprehensive, and so on. So it is very important to go step by step. It's not like it's not difficult, but it needs time and effort. And my suggestion to you is to start with ML.NET. My suggestions for you are related with going step by step and doing the things from the most, I would say, for example, you can start with binary classification and go through your journey and investigate another algorithms as well. So now I think it's time, naturally comes time to discuss about the Visual Studio and how we are going to utilize this concept. So for the demo, and we have enough time for that, we are going to talk about the lead scoring and lead decision strategies. Actually, we are going to talk about sales and marketing methodology, which are part of the lead generation process, automated lead generation. So shared sales and marketing methodology, I mean more on ranking leads. So we will have a scenario when we have a database of a lot of clients. So in this situation, we have the clients, we have a historical data of a clients of companies that become our clients. So the idea of the scenario is to try to find a pattern on the unseen data and to predict if some prospect or some company would become our client or our lead. So we are going to use a technique of assigning different values to the companies. And of course, we are trying to automate and guide the marketing and sales teams in the process of conversion the potential prospects into the customer and clients to our company. So the data set is publicly available. You can find it on Kaggle. And of course, I would use a data set that is pre-processed and processed. What does it mean? This means that all of this is part of the data science field. I mean, I've already done the data cleaning, exploratory data analysis, and data preparation of the data set. And I'm going to use a regression and classification approach. Mainly, I will use classification approach in the field of supervised machine learning in ML.NET. So because of this, I would like to just briefly introduce you in the concept of supervised machine learning and how actually supervised machine learning works. So imagine very simple scenario where we have cats and we have the machine. So we need to actually teach the machine to make a distinction between the animals or images from animals. So if we train the machine learning model to recognize cats, then if we actually put now different images from different animals, in this case dog and cats, of course, the machine learning model should be prepared to actually make the distinction that these are not cats, these are dogs, and these are cats. So the types of problems that are suitable to this scenario are the classification and the regression. Classification is actually sorting the items, classifying the items in two or multiple categories, which means that we have binary or multi-class classification. And on the other side, we have the regression. The regression is used when we are working with, for example, price prediction, or we are working with housing, with real values, real numbers. And why ML in this story? Actually, you will ask, because digital marketing and lead generation actually are generating a lot of data. So we have a concept of a lot of data, and we have a data that can be, or maybe it is not predefined or predetermined structured in some format. So for example, taking consideration different sources like CMS system, or maybe Excel file or Notepad file where we are storing a data about our potential clients. And after that, we have all of that historical data, and we need a lot of guys in the marketing and sales team to actually investigate, explore, try to find patterns and everything within the data in order to determine and to decide, okay, that client or that company could be interesting and could be our potential long-term client because of some stuff that we found as a pattern in the data. So we would like to automate this approach. We would like to automate this process in order to retrieve the power of the machine. So the power of the machine learning. So as a prerequisite, if you try to build something on your own, you should take in consideration that you should at least use Visual Studio 2019 with the .NET Core 3.1 SDK. And of course, I will show you how you're going to use the ML.NET extension and model builder. So I think it's time to start with Visual Studio. Marco, is there any other question before I go?
One more.
Okay.
Any way to avoid tutorial hell in this topic?
Sorry, once again, I'm not sure I understand well.
Any way to avoid tutorial hell in this topic? I understand this question as is there is possible to avoid tutorials and anything in this topic in some way? I don't know.
There are a lot of resources, so I would say let's connect, guys. You can write me. You can connect with me on my LinkedIn. We can share the mail. We will share the information, of course. Let's start step by step. I could support you. I could share a lot of interesting resources, which part of them are also injected in the presentation via the links. So part of them are actually from guys that are currently graduating. So you will find a lot of people that are just starting with the machine learning. So let's connect, write to me, and I'll be really happy to guide you, to support you in choosing the right materials, because there are a lot of materials on this topic. Okay, so this is Visual Studio 2022. So I'm using, you will see here, I'm using the version 17.0.2, and I'm also it is shipped with the .NET 6 framework. So first of all, what I would like to say, I would like to go to Kaggle to show you the. Before I go to Kaggle, this is my GitHub account where I actually just published the code. So you have the code here in the YES 2021 MLNet. I think that was in the master branch. You will find here the code, but I will go through the concepts right now. We have enough time for that. And of course, in the speaker deck, my speaker deck link that you will find in the presentation is actually, you can find the presentation here and all the resources that I'm talking about right now. And going in Kaggle, we are going to take in consideration one scenario which is mainly towards education, imaginary education company named X Education. So we have a database with all of these fields, which are actually retrieved after some campaigns. So we have like email campaign, or we have maybe website related promotion material about some campaign. We have a company that is actually taking an input from interested parties in listening some educational courses on their platform. So X Education is imaginary educational platform, and we are taking care about getting all of this data in order to actually have the interested parties about our courses. So as we have the data, I would directly drill down the Visual Studio. So I will first of all create one blank solution. Marco, can you please confirm that you are able to see the screen?
Yes, I'm seeing everything.
That's good. So I'm going to create one blank solution, and I'm going to name it lead generation MLNet. Okay, so let's create the solution. First of all, we've mentioned the prerequisites. Now I would like to say that before you're trying to use the ML.NET, you should go to the Visual installer and try to hit the modify part of the current instance that you are using. I'm using Visual Studio Community. So I will try to hit here the modify part, and you can go directly to initialize to the individual components. So here you should just search for ML.NET, and you should find and install the ML.NET model builder, which we are going to use in the demo. This is the first part, guys. The second one is within the Visual Studio. So as soon as you open the Visual Studio, go to the extensions part, manage extensions, and you should be able to find here the model builder as well. There it is. This one, created by Microsoft, ML.NET Model Builder 2022. Okay, this means that we are ready. So I will create one new project, one console application. You can, of course, I believe that you've already pre-installed the Visual Studio, the preview, or maybe this finally released version. You can, of course, use the filters here, but I will use a console application that is C# based, as you can see here. And of course, this console application, I will name it lead generation console. Okay, so this is the name of the application, and I'm going to use the .NET, the latest version of the framework .NET 6.0, which is long-term supported, and which was actually announced on the previous .NET conference. So a lot of great stuff was shipped with .NET 6.0. We are going to investigate it through the usage of the ML.NET. So I'm going to create the application, the console application, guys. It should be fast. All right, so we have the application which is following, as you can see, the new console template, which is part of the .NET 6.0. We don't have here the static void main function, but you can add it. If it's not a big deal, but this is actually part of the .NET 6. And of course, I'm going to show you also another interesting template regarding the web API. So here we have the application. Let's just verify that it is working, that everything is set up as required. So hello world, we are going to make this hello ML.NET from console application. Now, what can we do here is the following. We can actually right click on the project and hit add. So as you can see here, we have machine learning model, okay? So we have a machine learning model in this icon. Here it is. If there is a need to zoom it, please notify me. I think that is okay. But here it is, the machine learning model. Okay, so I'm starting, and this is the machine learning model template item that we have here. And it will be renamed. I will rename it as lead generation ML model. I will hit add, and hopefully you will see here the MB config file. So I would like to just go and show you that this MB config file is nothing but a JSON file. I can show you like this. It's JSON file that is keeping track of the state of the UI of the model builder. So if I go here and try to open it in Notepad++, you will see that it is a JSON file. For now, we are still at the beginning. So here we have different scenarios that are supported, fully supported by the ML.NET, and of course limited scenarios, which if I'm going to click them, you will find some additional information, and of course you will need Azure subscription to do them. But let me first explain that we have different scenarios like data classification, value prediction, image classification, recommendation for recommendation system, and object detection. We can use the ML.NET, we can build machine learning models locally, or as you can see, we can use the GPU or the Azure ML capabilities. So in this situation, we are facing with a scenario where we need to make a classification. What is our case? We have a data, historical data, and we need to know if some client will be converted as a lead, will be our long-term client or not. So I will hit data classification, and we are entering the environment part, or the setting the environment for building the model. So here, as you can see my local CPU environment, because for the data classification, we can use only the local CPU. And these are the parameters for my CPU at the moment, that I'm using at the moment. And also, as you can see, if I go next, here we have the first step of importing the data. Okay, so there are two possibilities so far. We can use it like a file with comma-separated values or TXT file. And of course, we can use a SQL Server instance. For this purpose, I will use a file which is stored here. There it is. And this file actually will be previewed within the model builder. Here it is. And this file, as I already mentioned, is a file that is a result of a pre-processing and processing techniques needed to be done before the machine learning is actually applied. But I'm just covering a broader scope, broader scenario for this presentation. You can, of course, start with some databases that I integrated as part of the presentation, where you initially would not need to take care about cleaning the data and stuff like that. As soon as you are going drill down more and more into the ML.NET and the ML concept in general, you can of course utilize and try to investigate the other techniques, of course. So here we have the data, and as you can see here, there are different fields. We are going to investigate them using the advanced data options. So here we have like some identification column, which I'm going to just ignore. So be careful how easy it is to prototype all of this. We have this column, and after that we have a column that is converted. Converted means that in this historical data, these specific clients were or were not converted into leads, or were not actually become our partners, our long-term clients. So in this situation, I will use this converted as a label. In supervised machine learning, we have a lot of columns, but just one should be label column, target column, which are going to be the column that we are predicting on. So this will be the column that is actually telling us if some part is some features, these columns are called features, if some features are going towards prediction 1 or prediction 0 in our case, or if the lead would be converted or not, the prospect would be converted or not. So as you can see here, the data is numerical, and this data here, these columns are scaled. So again, they are numerical. So I'm going to unhit the categorical fields of this preview. And in the meantime, as you can see here, we have the explanation, the column name, which is basically, you can see a lot of columns starting with the same structure, but that is because of the technique of dummy values. This is a technique from the data science part that is actually taking one column with multiple different options and spreading in multiple columns with 0 and 1s, like metrics. Nothing special here, but it was needed because it needs to be prepared and aligned like that to be used actually effectively by the machine learning models. So I would say this, everything now is set up related to the data. We are interested in the converted column, okay? So the next step would be, we have the data, we have configured the data. The next step would be to train the model. So when we are going to train the model, we are separating the data in train and testing set, which now will be done by default. But there is one specific moment that is time to train. So if you're not sure about how much time is needed to train a particular data set, you can just enter here 0 and hit start training. So you have here a table of how you should generally measure what time you need to actually train the data. So for now, I would say let's try with 60 seconds. So I will start training the data set with 60 seconds. This is the real power of the ML.NET. So as you can see here, we have so far found over 15 models with this accuracy so far, and we also have the best model previewed here. So now the ML.NET is utilizing, this is the model builder and AutoML concept, which is not just specific to the .NET, but it is used by the .NET ecosystem. And now you can see that we are exploring, automatically exploring, experimenting and prototyping with so far more than 50 models, with the best accuracy of one of them, fast forest over algorithm, over 80%. For just 60 seconds. So we are talking about 1 minute of our life. And let me just wait for the results. As you can see in the output window, here the detailed statistic of all the algorithms. So you will see here the algorithm name, and of course the accuracy and the other parameters. So for example, these are, we have here all the iterations, and of course the top 5 models explored and the best one that is actually going to be consumed. So we have the performance statistic, we have the accuracy, we have the best model so far. And now I'm going to hit next to come to the most interesting part, where you can see that this is the first row of the data set. Okay, so now we can use even the Visual Studio in the model builder to make a prediction. So now I'm making a prediction directly in Visual Studio, and I can say, okay, let me try with another data. Let me try here with once. Okay, so you can see that these columns actually are not columns that are influencing the result. Okay, so you can actually use the Visual Studio to evaluate the model directly within the ML.NET model builder. Okay, so this is the evaluate technique, which is actually systemizing the accuracy and what is the model. So fast forest over, you can find more about that. Fast forest over, MLNet, and you're directly into the documentation about the fast forest over. That is a binary triangle classification, which was found directly and derived by the mind of ML.NET. Okay, so now I'm going to hit next, and this is the most interesting part. I have 10 more minutes to show you. This is the code snippet that I'm going to embed in my application, and of course these are the project templates that we can use in order to integrate within a web API or maybe another console application. So now what I would like to say and show you, I will copy this code snippet and going directly here in the console application, paste it here, guys, and just reference the model from the application. And as you can see, this is pre-populated with the first row of the Excel file. Of course, we can tweak the parameters. We can use another input with not known data. But in this situation, you can see that we have the data and we have here the result, which is in form of model output. So if I go here and see lead generation ML model, lead generation ML model output, this is the type. If I drill down this class, you will see we have the prediction 0 or 1, converted or not converted, and we have an array of floats, which means we have the probabilities of some prospect to be converted or not converted as a lead. So we are talking about very significant prediction output that we get directly from the ML.NET. So now I can just write down here the prediction for this specific prospect is, and I can use here the string interpolation maybe, okay, is result dot prediction. So let's execute this. And I suppose that using the same data we should get 0, okay? Because as you can see in the evaluate part, 84% of the probability is dedicated to 0. So I can just tweak more this console write line, and I would say here with string interpolation, the potential of converting the specific client is, while of converting it is, and here we can use the result dot now score, and this is array of floats. So I will make this more beautiful, and also result.score, and I will use now the first field. So I should retrieve here results, okay, that are same as the results we get from the prediction in Visual Studio. So the potential of not converting the specific client is 0.84, while of converting is approximately 16%. So we are in the same moment getting an output that is giving us a knowledge about the lead score. This is called lead score, converted or not converted. And in the same time, we are getting the probabilities of successful conversion, which means that we are getting this is the lead score, this is the lead decision. So we have the lead score, the percentage, and we have the lead decision if that should be converted or not converted. Why this is important? Because we can investigate a lot of data, explore a lot of data using this approach, and we can just direct our marketing and sales team in the clients that are more promising and most promising to be acquired. So this is one scenario, and I will try to be as fast as possible to show you that you can use this as part of Web API. How? You can use it by going to the consume section, and I would like to show you now the JSON file. You see, the JSON file was generated by the model builder. Here it is. I would like to integrate one lead generation ML model Web API and to try to ping this via API testing tool, for example, Insomnia. So here we have the API, here we have the model. I will also briefly explain the files in 2 minutes. The main idea here is that I can go to the program part, just to be initialized. And you can see this is the minimal API design from the .NET 6. So here we have a predict endpoint that is directly mapped and following the minimal API design, which takes in consideration the model input, which is our class of input fields, and retrieves us the model output. So in this situation, let's just see the API properties. The API properties is localhost. Here it is. Okay, so I will start the API. Set up a startup project. Okay, and I will use Insomnia to show you that we can directly ping the API and benefit from using the model. Directly benefit from using the model. And this is of course applicable, and I have attached on Git with using the Azure functions. So I will just copy here and let's try it. This is the, here it is. Okay, now it is initialized. And we retrieve the same results. So this is as part of an API, okay? So this API could be a separate one or integrated as part of our application. How we actually, we've done this using the potential of the ML.NET and the files that are generated. This zip file, guys, is the file that is actually storing the model. The training file and the consumption files are structured as following. The training one is actually taking care about retrieving the best model. In this case, you can see that here we have, for example, all features that we are using, and we have the fast forest classifier that was retrieved as a best machine learning model. Everything wrapped within the ML.NET and ML context, and everything wrapped within a transformer, a pipeline, which can be utilized for tweaking the algorithm and, of course, creating the algorithm from scratch. But this is the automated way. And the consumption file is the file where we have the model output class we already looked at, and the model input class with all these input features, as well as something that is very important, the predict engine, which provides the predict functionality in our situation like we used here in the console application. And just for the record of time, let me just cover the key takeaways of this presentation. I believe that it was, first of all, interesting for you, but you should take in consideration that ML.NET is effective in prototyping and experimentation, and you don't need, as you already saw, you don't need a C# skills if you like to use the automated way of doing the things. You have a lot of scenarios that you can try. For example, image classification, object recognition, data classification, and so on. And you can embrace the automated ML approach and start from here. This can be like your initial step. Or if you are advanced, the ML.NET is not just a framework that is aimed to be like entry framework for entering the machine learning field. This framework can be, of course, utilized by machine learning experts using the automated way of prototyping, as well as coding the models from scratch, meaning that using the ML context and iTransformer interface, which I already showed, to build the models from scratch. And of course, the most important thing, ML.NET is open source, cross-platform solution that is fully flexible and extensible. So I really encourage you guys to visit ML.NET official site and drill down all the scenarios that are currently supported, see the roadmap, see the code on GitHub, actually try to find the best match for your scenario. For example, I was working in the pricing domain. So for me, the price prediction was the initial step of entering the machine learning algorithms. Now I'm using multiple scenarios for multiple business related reasons. So the Microsoft documentation is very comprehensive. So I believe that you will find a lot of answers regarding the infrastructure, technical answers, as well as beginning steps. But of course, feel free to contact me to connect, and let's discuss machine learning, let's discuss artificial intelligence, because 1 hour is it's very tight time to explain even the brief concepts with ML.NET. But thank you for your attention, and I really hope that the presentation was interesting and that you find a new perspective for the machine learning and the ML.NET after all.